The topic of the video is data centers and artificial intelligence, how AI and AI agents can transform data centers. Data centers are fundamental infrastructure for the modern digital economy. They provide computing, data storage, networking, cloud services, cybersecurity, high-performance computing, and increasingly specialized infrastructure for artificial intelligence, AI. At the same time, AI and AI agents can significantly improve how data centers are designed, operated, secured, maintained, and optimized. The relationship is therefore two-way. Data centers provide the physical and computational infrastructure required to develop, train, deploy, and operate AI systems. Conversely, AI agents, machine learning, digital twins, and advanced analytics can improve data center performance, efficiency, reliability, security, and sustainability. This two-way relationship creates substantial opportunities for data center owners and operators, technology companies, consultants, researchers, governments, and organizations using third-party data center services. I welcome collaboration with data center owners and operators, technology companies, businesses, government organizations, consultants, academics, and researchers interested in developing practical applications, technology solutions, consultancy projects, research grants, training programs, and industry partnerships in these areas. People can contact me to the following email address for comments and suggestions: Professor Dr. Sada M.N. Islam, NAS. Email address is lix8666@gmail.com. 1. Data centers as infrastructure for artificial intelligence. Modern AI applications require substantial computational resources. Training large machine learning and generative AI models may involve large clusters of GPUs and other specialized processors, high-speed networks, and very large datasets. Third-party data centers allow organizations to access this infrastructure without constructing and operating their own facilities. Businesses, universities, and government organizations can use data centers for AI model training, inference, data analytics, simulation, digital twins, and computationally intensive research. Data centers can therefore function as AI development and application platforms, supporting areas including engineering, finance, healthcare, manufacturing, water management, energy, transport, construction, fire management, and public administration. The expansion of AI also creates new requirements for data center architecture. High-density AI computing can increase electricity demand, heat generation, cooling requirements, and network traffic. Consequently, AI growth is influencing the design of power systems, cooling infrastructure, server configurations, networking, and operational strategies. 2. Artificial intelligence for data center operations. The second side of this relationship concerns using AI to improve the data center itself. A modern data center may contain thousands of servers together with cooling equipment, electrical systems, batteries, backup generators, network infrastructure, and extensive sensor networks. These systems continuously produce large quantities of operational data. Machine learning models can analyze this information to identify patterns that conventional monitoring systems may not easily detect. AI can support optimization of server utilization, workload allocation, cooling, energy consumption, maintenance scheduling, and infrastructure capacity. Instead of relying solely on fixed operating rules, an intelligent management system can continuously learn from operational conditions and recommend improved configurations. 3. AI agents and autonomous data center management. AI agents extend these capabilities beyond conventional predictive analytics. An AI agent can observe its environment, analyze information, reason about objectives, select actions, and interact with other software systems or human operators. For example, a data center AI agent could continuously examine server loads, temperatures, energy prices, cooling conditions, and application priorities. It could recommend or, subject to appropriate controls, implement workload redistribution to improve performance and reduce energy consumption. Multiple specialized AI agents could operate collaboratively. One agent might manage computing workloads, another cooling, another energy consumption, another cybersecurity, and another maintenance. A supervisory agent could coordinate their decisions against overall objectives such as reliability, service quality, energy efficiency, security, and operating cost. This creates the possibility of multi-agent intelligent data center management, although appropriate human oversight, validation, and governance remain essential. 4. Energy efficiency and cooling optimization. Energy is one of the largest operating costs of a data center. AI provides important opportunities for improving energy efficiency. Machine learning systems can analyze temperature, humidity, server utilization, airflow, cooling demand, weather conditions, and electricity consumption. Predictive models can estimate future cooling requirements and dynamically optimize cooling equipment. AI agents could coordinate cooling and computational workloads. For example, workloads that are not time-critical could potentially be moved between servers, facilities, or operating periods according to cooling capacity, renewable energy availability, and electricity prices. Computational fluid dynamics can also be integrated with AI to analyze airflow and heat distribution within data centers. AI-assisted CFD and digital twins can support cooling system design, identification of hotspots, and evaluation of alternative equipment layouts. 5. Predictive maintenance and asset management. Data center equipment must operate with very high reliability. Failures involving servers, cooling systems, power equipment, or networking infrastructure can produce substantial operational and financial consequences. AI-based predictive maintenance can analyze sensor readings, vibration, temperature, power consumption, and historical maintenance records to estimate equipment deterioration and failure probability. Instead of maintaining equipment only according to predetermined schedules, operators can move towards condition-based and predictive maintenance. AI agents can further support maintenance by monitoring assets, identifying anomalies, prioritizing maintenance activities, generating work orders, and providing technical information to engineers. Integration with digital twins can enable operators to test maintenance strategies virtually before implementation. 6. AI for cybersecurity and operational resilience. Data centers contain highly valuable information and provide services that may support critical infrastructure. Cybersecurity is therefore a major requirement. AI can assist with network traffic analysis, anomaly detection, malware identification, authentication monitoring, and identification of unusual user or system behavior. AI agents can continuously analyze multiple security information sources and assist cybersecurity teams by prioritizing alerts, correlating incidents, and recommending responses. However, AI-based security systems themselves require strong governance. Human authorization should remain important for high-impact actions, particularly where automated responses could interrupt critical services. AI should therefore complement rather than simply replace established cybersecurity controls, professional expertise, and organizational accountability. 7. Fire safety, emergency management, and physical infrastructure. AI applications are not limited to information technology operations. They can also support the physical safety of data centers. Sensors, computer vision, thermal imaging, CFD models, and digital twins can be integrated to monitor temperature, smoke, airflow, and equipment conditions. AI systems can identify abnormal conditions and support early fire detection. CFD simulations can model heat transfer, smoke movement, and ventilation under different fire scenarios. AI can accelerate analysis of large numbers of scenarios and help identify high-risk conditions. AI agents could integrate sensor information with fire models and provide decision support for isolation of affected systems, ventilation control, evacuation, and emergency response. This represents an important connection between data center technology and fire modeling and management. 8. Digital twins and intelligent data centers. A digital twin is a dynamic digital representation of a physical system. For data centers, a digital twin can represent servers, electrical infrastructure, cooling systems, airflow, energy consumption, and other operational components. Real-time sensor data can continuously update the digital twin. AI can then analyze the model to answer questions such as, what happens if computational demand increases by 30%? What cooling capacity will be required? Where might thermal hotspots develop? What happens if a cooling unit or power system fails? AI agents can use these simulations to evaluate alternative actions before recommending operational decisions. 9. Applications for data center users. The benefits extend well beyond data center operators. Organizations using third-party data centers can combine scalable computing infrastructure with AI and AI agents for applications including CFD and fire modeling, water quality, treatment and water resource management, energy system optimization, engineering simulation, smart buildings and infrastructure manufacturing and predictive maintenance, healthcare analytics, financial modeling and risk management, transport and logistics, supply chain optimization, government and public sector analytics, scientific and university research. The data center consequently becomes not simply a location for storing information but an intelligent computational platform for industry applications. 10. Costs and business considerations. AI-enabled data centers require investment in computing hardware, GPUs, storage, high-speed networking, sensors, cybersecurity, cooling and specialist personnel. Organizations must therefore evaluate capital expenditure, operating expenditure, energy costs, software licensing, data transfer, AI development and governance requirements. Third-party data centers can reduce the need for organizations to make large upfront infrastructure investments. Resources can instead be obtained according to workload requirements. The economic case should be assessed through measurable outcomes such as reduced downtime, lower energy consumption, improved equipment utilization, faster computation, better cybersecurity, improved maintenance and higher service reliability. 11. Research, consultancy and technology development opportunities. The convergence of AI agents and data centers creates significant opportunities for interdisciplinary research and commercial collaboration. Potential projects include AI-based energy optimization, intelligent cooling, AI-assisted CFD, predictive maintenance, cybersecurity agents, digital twins, autonomous workload management, fire safety, renewable energy integration and intelligent infrastructure management. These projects can involve data center owners and operators, technology companies, universities, engineering consultancies, government agencies and organizations that use data center services. There are corresponding opportunities for consultancy projects, software and AI agent development, industry-funded research, research grants, PhD projects, professional training and technology commercialization. My YouTube videos and areas of interest. My YouTube videos examine data centers from both sides of this relationship, how emerging technologies can improve data centers and how data centers can enable advanced applications across different industries. Topics include data centers and artificial intelligence, AI agents, CFD and fire modeling and management, water management, quantum computing and other emerging technologies. My areas of expertise and interest include artificial intelligence, AI agents, quantum computing, robotics, machine learning, data science, AI-assisted programming, analytics, digital twins, blockchain, cybersecurity, advanced mathematics and statistics, together with applications across engineering, infrastructure, business, health and government. Conclusion: opportunities for collaboration. The integration of data centers plus AI agents plus digital twins plus advanced computing provides an important foundation for the next generation of intelligent digital infrastructure. The opportunities operate in both directions. AI and AI agents can make data centers more intelligent, efficient, secure and resilient, while advanced data centers provide the computational infrastructure required to develop and apply AI across industry and society. If you enjoyed this discussion, don't forget to subscribe, like, and share. Stay tuned for more insights on AI, quantum computing, and emerging technologies shaping the future of software and humanity.